So we have a right triangle whose hypotenuse is 20 inches long and one of the legs is 10 square root 3 inches long. Let's quickly draw it out. Here's our triangle. Here's the 90 degrees. The hypotenuse is 20 and one of the legs is 10 square root 3. And we need to figure out which of these relationships apply to the smallest angle in the triangle. Well, you could be tempted to apply the Pythagorean theorem to find the length of this third side. But before you do that, let's quickly recall the two special types of right triangles we know about. So one of them is the 45-45 90 degrees triangle. So we have this angle as 90, this is a 45, and this one's a 45 degrees. What is the relationship between the side lengths? Well, if this is a x, this is also a x, and this one's x square root 2. Well, this times square root 2 is not going to give us 20. Therefore, we know for sure that this is not a 45-45 90 triangle. What about the other one, the 30-60 90 triangle? In a 30-60 90 triangle, we have the 30 degrees here. We have the 60 degrees here. If the side opposite the 30 degrees is x, the hypotenuse is 2x units long, and the side opposite the 60 degrees is x times square root 3 units long. In other words, if you divide the hypotenuse with 2, you get one of the sides, and if you divide the hypotenuse with 2 and multiply with square root of 3, you get the other side. Now look at this. The hypotenuse is 20 divided with 2 is 10, and 10 times square root 3 is this side. And therefore, this exactly matches the 30-60-90 triangle. This side has to be the x side, which is 20 divided with 2, and that's 10. And we know for sure that this angle has to be a 30 degrees, and this angle has to be a 60 degrees. This is a 30-60-90 triangle, in which the smallest angle measures 30 degrees. The right answer is answer choice B.
Let's begin by finding two cubes that have a volume ratio of 1 to 8. Here are two such cubes. So now let's compare their surface areas. The surface area of a cube will equal 6 times the area of one face, since each cube has 6 identical faces. In cube A, the area of one face will be 1 times 1, which is 1. So cube A has a total surface area of 6. For cube B, each face has a surface area of 2 times 2, or 4. So here we see that the total surface area will be 24. Now let's compare surface areas. Our ratio is 6 to 24, which simplifies to be 1 to 4. So the answer here is D.
A is the center of the circle, and the length of AB is 4 root 2. The blue shaded region is a square. What is the area of the shaded region? So the first thing we'll do is, let's just draw some perpendicular lines here. And so this is a smaller square, and the diagonal of this square is 4 root 2. Well, it's always true that if we have a square of side S, the diagonal is S root 2. And so if this is 4 root 2, the side of this square must be 4. So that's useful. So first of all, what that means is that the big square here, this is 8 by 8. So the square, area of the square, is 64. It also means that the radius of the circle is 4. Well, the area of the circle is pi times 4 squared, or 16 pi. And 64 minus 16 pi, we can factor out a 16 from both of them, and that's 16 times 4 minus pi, answer choice E.
Okay, to begin, this is a right triangle, so we can apply the Pythagorean theorem to get the following equation. At this point, we'll simplify both sides, and now we'll subtract 10 from both sides of our equation. If x squared equals 50, then x must equal the square root of 50. Now, since the square root of 49 equals 7 and the square root of 64 equals 8, the square root of 50 must fall between 7 and 8. So our answer then is D.
So this is an interesting one. If k to 3 is the ratio of circumference to diameter of a circle with radius x, and what is the ratio of circumference to diameter with a circle with twice the radius? Well, this is an interesting thing because the ratio of circumference to diameter is, by definition, always equal to pi for every circle on the face of the earth. For every circle on the face of the earth, circumference over diameter is pi. That, in many ways, is the very definition of pi itself. And so in the first circle, we see the ratio of circumference to diameter is k to 3. So k to 3, that must be a ratio that equals pi. And so any other circle in the world, doesn't matter how big or how small, the ratio of circumference to diameter is going to be that exact same thing. If k to 3 equals pi, then that is always the ratio of circumference to diameter. Answer choice A.
The area of a circular tarp is between pi over 36 and pi over 16 square yards. Which of the following could be the circumference of the tarp in inches? Right then, so we know that the area of a circle is given as pi r square, and it's given that this is greater than pi over 36 but smaller than pi over 16. So if we divide everything with pi, we get r square is between 1 over 36 and 1 over 16. And taking the square root, we have the radius of the circle lying between 1/6 and 1/4 of a yard. So this is in yards. As we need to find the circumference of the tarp in inches, let's convert this range to inches by multiplying everything with 36 inches per yard. So we have 1 over 6 times 36 is less than r is less than 1/4 times 36, and this time this is in inches. Simplifying, we get this is 6 and this is 9. So the radius of the tarp, the circular tarp, is between 6 and 9 inches. And we know the circumference is nothing but 2 pi r for a circle. So this is going to be 2 pi times the radius. 2 pi times 6, that's 12 pi. And 2 pi times 9, that's 18 pi. So the circumference of the tarp is between 12 pi and 18 pi. Now let's look at the options. We have a 14 pi that works. We have a 16 pi that works. None of the other options would work. So these could be the circumference of the tarp in inches.
Okay, so this is a tricky one. First of all, this is the length of 10, this is length of 32, this is the length of 40. Well, let's focus just on this triangle here. We have blank 32, 40. Both of these, of course, have a greatest common factor of 8, so let's just divide everything by 8 and see what happens. If we divide by 8, we get blank 4, 5. Well, of course, that has to be a 3, 4, 5 triangle. Scale back up by 8, this has to be 24. So 24 is the length of CD. That rectangle inside the circle is a 10 by 24 rectangle. I'm going to say, think about it this way. Divide it in half this way, divide it in half this way. And of course, that midpoint is the center of the circle. And so think about the radius of that circle. This is 5, and this is 12. Well, that has to be a 5, 12, 13 triangle. 5, 12, 13 is one of our Pythagorean triplets, and a very good Pythagorean triplet to know. That means that the radius of the circle is 13. The area of the circle would be 169 pi, pi r squared, by Archimedes' famous formula. And so if we're saying that this is in the form of k pi, k equals 169.
All right, let's begin with the information we have about our square. We know that the square ABCD has area 625. So from here, we know that each side of our square must have length 25. Let's label 2 of those sides. Now on to the rhombus. We know that the rhombus has area 500. We also know that the area of any rhombus is equal to the base, which in this case is 25, times the height. Well, from here we know that the height must equal 20, since 25 times 20 equals 500. At this point, I'd like to take the shaded region and divide it into 2 regions. We now have a rectangle and a triangle. So our goal here will be to first find the area of our rectangle, and then find the area of our triangle, and then at the end add both of these areas together. Okay, let's begin with the rectangle. We already know that the rectangle has a width of 25. We just need to figure out how high that rectangle is. Well, we already know that the length from A to C will be 25, and we also know that the height of our rhombus is 20. So from this, we can conclude that the missing piece of our blue rectangle will be 5. So from here, we can calculate the area of a rectangle. It equals 25 times 5, which equals 125. Now on to the area of our triangle. Since the height of our rhombus is 20, we know that this side of our triangle must have length 20. Also, since all 4 sides of a rhombus have equal length, we know that this part of our triangle has length 25. At this point, I'd like to take this triangle and move it over to the side here, and we'll label our missing side x. From the Pythagorean Theorem, we know that x squared plus 20 squared must equal 25 squared. We can simplify this equation, and now we can subtract 400 from both sides of the equation. From here, we can see that x must equal 15. Now that we know the value of x and the height of our triangle, we can calculate the area of our triangle. It equals 15 times 20 over 2, which equals 150. So the total area of our shaded region will be the sum of 125 and 150, which is 275. So our answer is E.